Hello everyone. Today let us discuss about spread spectrum. What is spread spectrum? It's a communication technique in which the transmitted data is spread over a bandwidth much wider than the minimum bandwidth required to transmit the information. Spreading, how the spreading is done? It is done using pseudo noise code or PN code, which is known only to the transmitter and receiver in order to improve security and reduce interference. The figure 1 or figure A shows the spread spectrum signal is spread over a bandwidth much larger than the narrowband signals. So spreading the transmitted power over a wide frequency band great reduces the signal power in a narrow bandwidth and potentially that is for interference, potential for interference. And the below one is nothing but a D spreading. So here most of the power is concentrated in the middle one. So the total power the spectrum signal into the narrow band. So high peak power signal. So whereas the potentially interfering more narrow band signals are spread out. So that the power in the bandwidth of the desired signal is relatively low. Let us see the advantages of spread spectrum. So allows higher transmitter power for unlicensed wireless devices and reduces interference from other users sharing the same frequency and minimize multipath interference, which improves the signal quality and protects against jamming, whether intentional or accidents, and provides better security by making signal difficult to intercept and allows multiple users to communicate on the same channel using different codes. So that is nothing but code division multiple access or CDMA. There are two types of perspective technique. One is frequency hopping spectrum and the second one is direct sequence spectrum. In frequency hopping spectrum, the carrier frequency changes from one frequency to another at regular intervals according to PN sequence, which is known to both transmitter and receiver. Whereas in the direct sequence spectrum, the signal is modulated by a PN sequence known to the receiver. So the performance of both the spectrum signal is related to a property called processing gain. So processing gain is defined as the difference in dB between output SNR after despreading and is input SNR to the receiver. So output the difference between output SNR to input SNR is known as processing gain. Apertures can be divided into two classes, fast hopping and slow hopping. In fast hopping, the frequency will be changed one or more times per data bit, whereas in slow hopping, several bits will be transmitted per hopping frequency, so it is used for fast data rates. So here you can see the frequency hopping spectrum, so which is plotted between the frequency hop versus time period. Here you can see the number of available carrier frequencies F1 to F9. Each horizontal block shows the frequency used for transmitting data during the slot. So after one time slot, the transmitter changes or hop to another frequency. So data transmission starts from frequency F4, then it switches to F7, then it hops to F3, F2, then it goes to F8. Then the receiver follows the same hopping pattern using the same pseudocode. The diagram shows the transmitter and receiver of FHS. So here the data input data is modulated by the modulator. Then the carrier frequency is controlled by, for modulation we need one more signal, that is carrier signal. The carrier frequency is controlled by, our carrier signal is controlled by the frequency synthesizer. Then the modulator signal is transmitted through antenna. So before that the signal is getting amplified by RF amplifier, then transmitted through the antenna, then the free space the signal is transmitted. The receiver side we are having receiving antenna, so which receives the signal. If there is any noise present in it, then which is removed by low noise amplifier, then applied to the mixer. So where the signal is getting mixed with the receiver local carrier frequency, local oscillator carrier frequency, so which is controlled by frequency synthesizer. So the receiver first detect the beginning of the transmission, then synchronize its synthesizer to that of transmitter. So once when the receiver knows the pseudo pattern of the transmitter, it can lock onto the incoming signal. So then once exact synchronization has been obtained, then IF frequency will be given out. So then the IF signal is amplified by IF amplifier, then that is given to the detector. So detector is a demodulator, so where the reverse process of modulation takes place, the data is extracted from the modulated signal, then we will be getting the output signal. And then this is the transmitter diagram of a direct sequencer spread spectrum. So here we can see modulator. For modulator, one signal is data and another signal is the output of mixer. So here the pseudo random spread code modulate the transmitted carrier frequency, which is modulated by data. So here the use of pseudo random code is spread the transmitter signal over wide bandwidth, and this is the frequency spectrum of direct sequence spread spectrum. So here we can see the lobes. So this is called main lobe and these are called side lobe. So most of the transmitted energy is present in the main lobe, and the side lobes have very little energy, and the energy gets decreased, gradually decreases for the side lobe. So here the required bandwidth is 2 into chip rate. So twice the chip rate. So the received signal has very low SNR. So that is often it is less than 0 dB due to wider bandwidth. At the receiver section, so the same PN is used to recover the original data. This is the receiver section of DSS. So the receiver multiplies the replica of the transmitter's spread code with local oscillator frequency, so which produces signal which is mixed with the incoming signal. When the transmitter and receiving spread codes are same and are in phase, then narrowband IF signal will be generated. So then the signal will be demodulated. So two stages to synchronize the transmitter and receiver pseudo codes are acquisition and tracking. So in order to acquire signal, the receiver multiplies the known expected code with incoming RF. If the output is random noise, then the signal will be that is when the signal other than the desired signal is in the channel. So when the desired signal is present, and it must be synchronized in phase with the receiver code to achieve the correct output. So in synchronization, tracking keep the transmit and received code bits aligned for complete duration of message. The relative advantages of FHS and DSS. So FHS can be designed with less power consumption than DSS. Acquisition time is lower in FHS. FHS has high interference immunity, and DSS provides higher data rate with less redundancy, and it has more flexibility. RFID transceiver. So RFID transceiver is a device that sends radio wave to RFID tag and receive the tag response to identify or track an object. Instead of having two separate transmitter and receiver terminals, RFID system consists of reader that send signal to active or passive tag and then receive the signal from it. So one or more tag or smart cards interrogated by the reader to obtain the ID of each, and the data will be sent to the host application. So some type of tag or card may be written to as well. So other tag includes sensor whose outputs are read to the host. And the applications of RFID. First application is aircraft identification. So let us see the four different applications of RFID: aircraft identification, roadway toll collection, inventory control, and animal husbandry. So aircraft identification, aircraft identification. A terrestrial terminal radar, for example, transmitter data or beam in the direction of aircraft. A transponder in the airborne vehicle responds by transmitting an identification code to the initiating terminals, which can be used to mark the radar screen. So it is used used in wartime to identify the friend or foe. And the roadway toll collection. So signal from overhead transmitter and a toll route activate transponder that is mounted on a vehicle, which transmit car ID to toll station receiver for billing purpose. Then the next one is inventory control. So tag on product in a waterhouse reflect a signal to the handheld reader. So to identify the content of the box. Then it is also used in animal husbandry. So embedding a tag in a house or any animal is read by RFID readers. So when the animal comes for milking for some purpose, and that is used to across the statistics of milk output for each individual cow. And these are the design issues related with RFID. So the first one is tag orientation. So it's like tag orientation is likely to be random. So tag and reader antenna must be designed to give required range for any orientation. Then multiple tag. So within the transmission range, which can cause a return message collision. One way to avoid this by using tag random delay for responses, which may allow several tags to be interrogated at once, and the tag must be coded to prevent misreading. Antenna. Antenna is a device that connects transmitter or a receiver to the free space. It transmits and receives electromagnetic waves. The performance of any wireless communication system mainly depends on antenna. The principal properties of antenna are directivity, gain, and radiation resistance. So directivity means the direction in which antennas send or receive the strongest signal. Gain is the ability of antenna to improve the signal strength. Radiation resistance indicates how efficiently antenna converts electrical signal into electromagnetic signal or radio waves. The principle of reciprocity states that the power transferred between two antennas will be that is regarding of regardless of which is used for transmission and reception. If the generator and load impedance are conjugate of the transmitting and receiving antenna impedance in each case. So the characteristics of antenna. That is the first two characteristics is antenna impedance. So antenna impedance facilitates efficient power transfer between the transmitter and receiver and the antenna. Proper impedance matching improves signal transmission and reception. So antenna impedance either is a load for the transmitter or input impedance to the receiver. It is composed of three parts: radiation resistance, loss resistance, and reactance. Radiation resistance is nothing but a conversion of electrical power into electromagnetic waves. Loss resistance represents the power lost as heat in the antenna, and the reactance nothing but stores electrical energy and affect impedance matching. The second characteristic is directivity and gain. So the directivity describes how antenna focuses its signal in a particular direction. So the antenna with high directivity send more power in one direction. So an antenna which radiates equally in all direction is called as isotropic antenna. Such an antenna doesn't exist, and its directivity is 0 dB, that is 1. Directivity high pole antenna is 1.64 or 2.15 decibel. The directivity is defined as the power density of antenna in its direction of maximum radiation divided by its average power density. So D equal to maximum power density by average power density. And the next characteristic is effective area. The effective area is it shows the capturability of antenna of a given gain. So it is proportional, grows proportionally as the square of wavelength. So G, where G is the receiving gain, receiving antenna gain, lambda is the wavelength, and A is the effective antenna area. The power density of the antenna is nothing but the radiated power divided by surface area of the sphere. So the electrical power strength is E, then the power density is given by the formula AC equal to E squared by 120 pi. And the received power can be calculated when the electric field is known by using the formula PR equal to E squared by lambda square GR divided by 480 pi square. So power captured by receiving antenna is nothing but a capture area, effective area of antenna into power density at the particular location. Polarization. So polarization is the direction of electric field of the radio wave. So electromagnetic magnetic radiation consists of both electric and magnetic field. So these fields are perpendicular to each other and to the direction of wave propagation. So there are three types of polarization. One is linear polarization, second one is elliptical polarization, and the third one is circular polarization. So linear polarization is produced by straight wire antenna. A wire antenna parallel to earth is horizontally polarized and the wire antenna normal to earth is vertically polarized. In elliptical polarization, the electric and magnetic fields rotate in an elliptical manner. So this will be produced when two antenna elements are fed with different phase angles. In the circular polarization, the electric will rotate in a circular manner, that is a complete 360-degree. So it produced when two signals have equal power and 90-degree phase difference. Helical antenna produce elliptic or circular polarization. These are the right and so two types of electrical polarization, right hand and left hand, so which are distinguished by the direction of rotation of electric field. So the polarization of wave antenna is important for several reasons. Horizontally polarized horizontally polarized receiving antenna cannot receive vertically polarized radiation from vertical antenna and vice versa. Similarly, right hand and left hand antenna systems are not compatible with each other. So, except for directional line of sight microwave system, the polarity of a signal may change during propagation. So, between transmitted and receiver because of reflection. Then cross polarization is the cross polarization is nothing but the degree to which transmission from antenna of one polarization can be received by antenna of the opposite polarization. The next characteristics is bandwidth. So antenna bandwidth is a range of frequencies over which antenna can operate while some other characteristics remain within the defined range. So it is related to antenna impedance. A narrow bandwidth or high quality factor antenna will operate over a small frequency range which reduces unwanted signal and interference and requires less amount of filtering. The last characteristic is antenna factor, which is used to measure the strength of electromagnetic field. It relates the field distance to voltage, which relates field distance to voltage. Voltage across antenna terminals when antenna is terminated in a specific impedance, that is usually 50 or 75 ohms. So the antenna factor is given by E by V. So where E is nothing but field distance and V is the load voltage. And it is antenna factor is measured in terms of meter and in dB it is given as 20 log E by V. Types of antenna, various types of antenna. Now first one is dipole antenna. So wire antenna, that is fed, it is a wire antenna that is fed at the center. Its length is lambda by 2 and the radiation resistance of dipole antenna is 73 ohm in free space. It is usually mounted in horizontal direction. So radius is strongest in direction perpendicular to the wire and the directivity of dipole antenna is 1.64 or 2.15 dB. So nearby ground or metal object, the radiation pattern will be getting changed. So it works, generally it works well indoor because of reflected signal from walls, floor and ceiling improve coverage. And it is easy to connect to transmitter and receiver due to 73 impedance. Advantages are it has high efficiency and in spite of its many attractive features, the half-wave dipole antenna is commonly used with is not commonly used with short range radio equipment. So it is used in TV and radio receivers. This is a radiation pattern of dipole antenna. The second type is ground plane or monopole antenna. So which is commonly used in cordless phone, cellular phone, CB radios and walkie-talkies, which is made by one half of dipole antenna mounted vertically on a metal ground. So it acts like a missing half by creating a virtual or reflected element. It uses lambda by 2 vertical antenna. The antenna is shorter than lambda by 2, then the efficiency will be decreased because of low radiation resistance and high capacitive reactance. So a coil is added at the bottom to increase the electrical length and improve the performance of the antenna. Then this improved version is known as helical antenna, which provides higher efficiency. And the next one is loop antenna. So this is popular for handheld transmitter because it is small and printed on a circuit board. So it is less affected by nearby metal object than other small antenna, and it is commonly used in handheld remote controllers like low UHF frequencies. And the main drawback of loop antennas are very low efficiency, radiation resistance is very less, that is less than zero point 0.1 ohm, and efficiency is below 10%. The performance can be improved by increasing the number of turns and increasing the loop area. Loop antenna. So because of low efficiency, it is rarely used in UHF short range receivers, and it is used in pager receiver because they work with low data rate and high sensitivity. One advantage of loop antenna is it doesn't require ground plane. So this is suitable for low power license-free transmitter where high efficiency is not essential. And the fourth type is helical antenna. So helical antenna gives better results than loop antenna when radiation efficiency is important, while still maintaining a small size compared to dipole or quarter wavelength wave ground plane. So this is made by winding a stiff wire in the form of a spring whose diameter and pitch are very small than wavelength, or winding a wire on a cylindrical form. So compact antenna which better performance than loop antenna. So it is resonant, but efficiency is lower than the standard quarter wave antenna. It is made easy to mate with transmitter and receiver since the impedance matching is very simple. Produces both vertical and horizontal wave. So polarization is elliptical and requires good a ground plane for best and suitable performance. Widely used in satellite and space probe communications. The last one is a patch antenna. The dimension of patch antenna is approximately half wavelength, which is calculated using the formula lambda by 2 root epsilon. The patch antenna is slightly less than half lambda by 2 because of bringing effect. Only two opposite edges are radiated when the feed is placed in the center. So microstrip feed line is used because it can be printed on the same PCB as the antenna. The feed point impedance depends on the width of the patch. Your 50 ohm coaxial can be connected directly to antenna through a wire with a shield connected to the ground plane. So patch antenna generally used in microwave frequencies, and this is made up of a metal patch on one side of PCB and ground plane on the other side. So available in different shapes such as rectangular, circular, and trapezoidal. So radius maximum energy perpendicular to the PCB side. So PCB side. A square half wave patch antenna has a directivity of 7 to 8 decibel. So these are the various types of antenna. So the types of antenna, orientation or polarization, length, radiation resistance, efficiency, gain or directivity, applications. So now for dipole antenna, the orientation is horizontal or linear. The length of dipole antenna is lambda by 2. Radiation resistance is 73 ohm. It has high efficiency, and the gain or directivity is 2.15 decibel, and it is used in TV and radio receivers. Then the monopole antenna, it is vertically polarized The wavelength is lambda by 2 and the 36 ohm radiation resistance. The efficiency is low and it has a directivity of 5.14 decibel used in wireless phones, vehicle antenna and walkie-talkies. Loop antenna has a polarization of horizontal or vertical and linear. Its wavelength is lambda by 10 to lambda, varies from lambda by 10 to lambda and has a radiation resistance of zero point 0.1 ohm and efficiency is less than 10%, but gain depends on the size of loop. It is used in RFID, UHF, ultra high frequency receiver, magnetic field sensor, page receiver, helical antenna. So polarization or horizontal vertical CP or EP. The wavelength is multiples of lambda by 4. The low radiation resistance and the efficiency also low. It has a high directivity in the range of 10 to 20 decibel. It is used in satellite communication, GPS, space communication, and patch antenna. So patch orientation and polarization are LP and CP. Lambda by 2 square root of epsilon and high efficiency. The directivity is 7 to 8 dB used in mobile phone, Wi-Fi and